times. And safety is critical to the success of industrial robotics historically. And we have standards for those. Our association developed the first American National Robot Safety Standard back in 1986 that became the basis of the current ISO standard. But in some of these use cases, I don't know if there are such standards. And so I'd like to start with you, Andrew. What do you do to make sure that your applications are safe?
It's a great question, because that's where our company got started. I saw window washers almost lose their life, and as they were hanging on for dear life, I wondered why wasn't there a better way to get the work done. So safety is really at the core of what we do, and the first thing we focus on is the technology itself. So as a good example, a lot of our drones are being flown in these urban environments with a lot of electromagnetic interference. It's where most drones can't operate today. So we figured out what's the right array of sensors to allow us to operate safely in these environments. We have redundancies and things like our heading and a lane switching algorithm that goes from sensor A to B to C, depending on the quality of data it's getting, so that the customers have a really easy, smooth flight. And then beyond that, there are dozens and dozens of fail-safes that go through. Well, what if a battery fails? What if a transmitter's lost? And then the other half of the equation is really looking at the operational profile. We often talk a lot about what is the worst case scenario. For us, our worst case scenario, I could sit here and tell you how much every part on a drone or robot costs and how long it will take to repair it. In the traditional method, if somebody falls from 10 stories, that's somebody who doesn't get to go home to their family at the end of the day, and you can't put a price on that.
Nathan, how about you?
Well, safety is a huge part of what we do, and especially because, one thing we realized early on is most people would think we'd use collaborative robots to do what we're doing, but we actually need industrial robotic speeds, and kind of the dirty little secret of collaborative robots is that they're slow robots, especially if you put something pointy in their hand. And so we needed a way to get the robots completely away from the person. So what we did is we put the robots in a big box where the client's face is presented to the robots in a way that all the robotics is physically stopped out and can't possibly get to the person. And then we put in its hands little spindly tools. We call them featherweight because they're literally the weight of a hawk feather. And then we took advantage of the fact that you don't need really hardly any force to handle eyelashes. And so we took those tools and we attached them to the robotics with little magnets. So if you were to go up to our machine and hit the tools with your finger like this, they just fall off. So if there's a session going on and someone were to, sneeze and thrust their head towards the tools, they just fall off. We put on clean ones and keep going. And, that's the key part of the safety system. But most of my team, our last startup we did together was a medical device. So we followed the ISO standard for medical device hazard analysis and look at all the hazards in the machine that way. And like you said, we're not required to do that because we're a cosmetic device. But we do the same thing we did with the medical device because it just really makes sense to make sure you looked at every possible way you could hurt the person.
Mariana, you want to weigh in?
So we at Infineon, we are a solution provider to the customers like Nathan and Andrew, and what we do is we extensively test and evaluate our devices to provide functional safety. We do that from the hardware perspective and software perspective. From the hardware perspective, we put through tremendous stress our devices. We follow the same standards as they do to make sure that they get what they need. We also provide all kinds of different tools like functional safety libraries where they can use to make sure that the codes are not functioning actually properly and so on. I would like to add maybe one more point here that is not necessarily safety, but it is attached to safety, and that is security. I think that security is a very important topic because security, providing the secure solutions and security tools to our customers is also extremely important in terms of safety because many of these robots can be hacked And that doesn't apply to every single application, but for robotics application, it does apply as a safety essentially requirement. And for security, we also have different levels of security. We also follow PQC, post-quantum cryptography, and we are providing tools basically against the future attacks.
Rahul, anything to add?
Yeah, for us, this is something we've embedded to our digital twin capabilities very extensively, where we can simulate the robot working in the environment, in a structured environment, in an unstructured environment, with humans in the loop. We have digital twins of the humans. We have different kinds of digital twins of humans depending upon which country, which region of the world they are in. So we can completely simulate and validate the reach, extensibility, and the interaction of the robot and the human in a very, very fine-tuned manner. And where, to add just another point on that, where we have extended that capability in a big way now is with AI, where we can simulate thousands of situations and edge cases as well to see what could be potentially some problems and make it really fail-safe and sure that we are not going to be encountering any potential issues.
You know, when we had a show of hands, it looked like a lot of people in this room still are new to robotics. And with this experienced panel here, I thought it would be good to have them share their advice for how to get started with adopting robotics, or even how to get started with launching a robotics company. So maybe we'll start with you, Nathan.
I guess I would speak to the how to start a robotics company. I would say probably the most important thing is to have a co-founding team that has some track record or connections to the venture capital world, because the real issue with robotic startups is just getting them financed, because 95% of the VCs out there are used to financing software projects, and they have a set of software metrics that when they come to robotics, they're like, what do you mean you can't get to $1 million ARR without a Series A? They just don't get it, right? So I think that you want a founding team that really is set up to raise money. That's the most important thing.
Yeah, I'll go ahead and dive in on advice to anybody looking to start a robotics company. The first thing I'd really urge you to consider is, what is the problem you want to solve? I think a lot of time and capital in our industry has been wasted by robotics companies who are born out of research. They go and build foundational technology, and then they look for problems to apply it to. That is an awful way to start a company. The much better way to start a company is be born from industry. Find a specific problem you want to solve. Figure out the technology to solve that problem, and then expand. The other thing I'd encourage you to think about is, what is the magnitude of the problem you're solving? Is it incremental or transformative? I hate to see a lot of robotics applications today that are 10, 15% better than the traditional method, when there are so many applications out there that could be 2 to 10x more efficient. And then to anybody out there who's looking to adopt robotics, I'd recommend really thinking about 2 things. One is, assess your workforce. Are they ready to work alongside robots? Because at the end of the day, the adoption from the people at the ground level matters a lot to a successful robotic operation. Then the second thing is, vet the robotics provider. Ask them about their training program. What does their maintenance cycle look like? How quickly do they turn around repairs and reduce downtime? Robots are in the very early phases of development still, and they need a lot of ongoing maintenance. So it's critical to ask those questions.
Yeah, I can jump in, actually just complement what they already said and maybe put a little wrapper around it, that when you're looking at the use cases and the problems you're solving, think of the whole system, right? The robot is one piece of the technology, but you have to think of the entire system and how will you solve the problem using the robot as a technology. Robots are not the ones who typically fail, it's the whole system is where you're not able to figure out how to get that work in the right way, how to get it effectively used. That's where we have found the biggest challenges customers face. So I think if we can figure out how to get that evaluated and get that defined effectively in the beginning, it becomes a lot more easier to move forward.
So after you get money, funding, the founder, and everything, all these basics, right? So basically, what my suggestion would be after that to find the partners for solutions in your robots, right? So Infineon is semiconductor company. We create chips, different types of chips, but today we're not only about semiconductors and the chips themselves, we're about solutions, and we're not the only one in the industry. So the most important part, in my opinion, after you satisfy these basics, is to find the right partners to help you out with these subsystems that you really need working for you. And many of us are really open to work with you and partner to create solutions if they don't already exist. But in many cases, we have solutions existing in our libraries, and we can share those.
One of the pieces of advice that our association gives to companies who are just starting to adopt robotics is what we call to start smart. Don't try and do everything up front, you know. Don't tackle the hardest problems up front. Tackle things that are achievable and get them into operation and then scale from there. Because I think too many people think, well, it's really impossible job, we're going to have a robot. Well, if it's an impossible job for people, it's probably going to be difficult for robots as well. One of the things we talk about with robotics is it's not just the robot. There's all these enabling technologies that go along with it. And Ariana, I think I'd like to start with you on that. What do you see are the importance of the enabling technologies, and which ones do you think are really most critical?
In robots, robots are very specific in this entire AI ecosystem, and robots are the ones that basically bridge the physical with virtual. So in this physical world, what's important is to actually get this physical world and be able to sense it, be able to actually manage the information that you sense, and to provide the feedback in terms of the action out. All that requires very fast communication. It requires the active decision making. It requires a lot of technologies that are needed to support that. In addition to that, the efficiency of the robots, because robots are not going to be hooked to the wall. Robots need to be free in order to actually be useful to us. So efficiency is extremely important, right? Efficiency doesn't depend on the weight of the robot. It does depend on the technologies used and so on and so forth. So all of these are super important in the whole ecosystem. In addition, of course, tools, software tools for different types of security, safety, which we mentioned already, that can contribute to the whole ecosystem of the robot that can be pushed out as a product.
What do you think?
Yeah, to me, I think having lived in this personally in the world of the digital twin, I cannot even imagine how you can be trying to build a company and try to function without having a digital environment to test, validate, design, engineer, manufacture, use it all in the virtual world where you don't need to worry about problems, you don't need to worry about something crashing, you don't need to worry about someone getting hurt. Get all of that evaluated, tested, built, designed, engineered in the virtual world using a digital twin, and then you bring it to the real world. To me, there is no other way. I think it's the most important thing that you got to be thinking about in your entire thought process. Whether you're someone who's building a robot, whether you're someone who's manufacturing one, or someone who's planning to use it. If you have a digital twin in each of these scenarios, you are going to dramatically accelerate your adoption process.
Nathan?
So I think it's really interesting that when I started in robotics, which I don't want to say how long ago that was, if you told me that you needed to put a 150 micron fishing line through the eye of a size 20 fish hook, which is tiny, The first thing I would have said to you is, well, first we have to figure out how to build a mechanism that's accurate to plus or minus 20 micron or something like this. And you would say, like, but wait a minute, my hand is certainly not accurate to plus or minus 20 microns, so why can it do it? And that's because you are essentially like embodied or physical AI, or I guess your physical eye. You're using vision, and you're wrapping a servo loop around it, and you're correcting as you do it. And so I think that just computer vision and then the neural networks you need to process all that vision data fast enough are essential in this generation of robots, where we don't need to build robots anymore that are plus or minus 20 micron robots. We just need robots that give smooth output for smooth input, just like my arm does. Like if I close my eyes and you tell me move 100 millimeters, I can't do it within probably 10 millimeters, right? But I can do incredibly accurate things. So I think that that's really interesting. And then I think you mentioned simulation. I think the combination of simulation, if you can get a good enough simulation to use reinforcement learning on the simulation, then you can really start to develop some very exciting control that we just couldn't have dreamed about in the past. And then you can move that over to the robot and start doing it in real life and learning even more.
The last thing I'll add, because there are three great perspectives on the technology side, is when you're building frontier technology, you naturally have to solve a lot of frontier problems. And going from 0 to 1 on a robotics application, it's time intensive, it's capital intensive, but not enough people talk about the 1 to 100 journey, the 100 to 1,000 journey. So there's a lot of unsexy parts of the business that need to be built beyond just the physical and software systems. So that's your production line, QA, QC, building out scalable training. And the one I will talk about until people get sick of it is really talking about ongoing maintenance plans and servicing for these robots. And when you zoom out and think about another industry with a lot of parallels, the automotive industry, we've been building cars for over a century. A ton of our best minds and money has gone into making these great machines, and they break down all the damn time. So it's almost unrealistic to expect that drones and robots at this much earlier stage of evolution won't need a lot of maintenance. So that's one thing I want to emphasize beyond just getting the technology to work at the start, is building the complementary parts of the business to really scale the impact.
So artificial intelligence is being talked about in every session probably here at the event. It's changing the world quickly, but how do these advances in artificial intelligence impact the current and future robotics applications? I mean, are there some things that you see happening in the near future that aren't happening today because of AI? Let's start with you, Rahul.
Yeah, great question. To me, I think what AI has done is expanded the world of usage of robots. They were confined to a limited space, to a structured environment. Bringing in AI has expanded the usage of robots in a completely unstructured world, giving them the ability to become a lot more free and a lot more usable in many different applications. The one thing I just mentioned very briefly right at the beginning about the example of Disney. Think about it, they are probably the most creative set of engineer brains working out there, and they are using now AI and robots to make a lot of the parts and products that they have on demonstration, or not demonstration, but in usage in their parts. All of that has been possible because of bringing in AI into the manufacturing process, for making shapes of rocks, making shapes of trees. That's not possible without AI. So using robots to make those things is all possible because of that. So that to me has been one of the biggest advantages, and then using it further to continuously learn and bring that feedback into the process, so helps accelerate the adoption and usage of the robot in a very, very effective manner. We have seen companies using the learning capabilities to drive a lot more speed and production and throughput and through that whole process. So I think those are the two important elements: the unstructured world that it introduces us, and the learning capabilities that become very easy.
Mariana?
I think that the way I see AI in the robotics is basically helping the physical AI become really alive. So far, we have seen some attempts at it. For example, the vacuum cleaners, robotic vacuum cleaners. Whether that was the real robotics or not, that's a different story. Then today we are seeing a bigger step forward as humanoids. I think that where we want to get today too is to robots to really be independent contributors to enhancing the skills or the support or services that we need enhanced. So that's one aspect of it. And then a second aspect of it, I think what we are going to see is what we've seen in the past already is, for example, complete automation of some of the processes that we have currently. For example, the fabrication of wafer fabrication we've already seen. I've heard from Raul that we have examples of the fabrication of the appliances and so on, completely without humans and so on. So I think some of the manual jobs are probably going to be replaced by some of these fully automated fabs.
I think that what AI is doing is enabling just a completely different class of applications that, you know, either were impossible before or were basically impossible because they would cost too much. I think that one of the reasons I call what we do the quarterback sneak of robotics is that it's not that hard. So what we can do is we can do everything we need to do with classical old school techniques pretty well, not great. And then we can use that to get a bunch of real world data, which we use to train neural networks, and then we get higher performance, and we replace all that old code with neural networks. But, you know, when you look at more complicated applications like humanoid robotics, I mean, everybody's seen the killer humanoid robotics demos of oh gosh, I'm forgetting the guys up in Boston Dynamics. You've seen their demos they were doing before all this reinforcement learning. Well, that was all paid for by DARPA, and it's hundreds and hundreds of man years it took them to get to that point. And now we're just going to be able to let the robots learn how to stand and walk and to do things actually useful with their arm. And frankly, I don't think before there was really a reasonable way to do reinforcement learning in the real world, I don't think humanoid robots could even be thought about, because there'd be no way to pay for all the programming you'd need to do to get them to reach behind the seat of a vehicle and plug something in. It's just, it'd be impossible.
I'll end by saying we love AI. One of the most beautiful things that's happening inside a lot of robotics companies like ours is software timelines are compressing. We're now able to create more and more valuable output with less and less time, less and less people. And software is pretty expansive in robotics. You've got the onboard controls, the mobile apps, the fleet management, the data analytics. So we're picking up a lot of momentum and delivering more valuable to customers without as much capital needing to flow into it. And the other thing people are talking a lot about, of course, is physical AI. As anybody who's ever used ChatGPT knows, the better prompt you give it, the better context you give it, the better output you'll get. Well, in robotics, you need very specific data to get better output when it comes to AI. And real-world data is like the holy grail. So what we optimize for at our company, our North Star metric is ROM, robot operating minutes. So we know the more robots we deploy, the more data we'll collect, the more product insights and learnings we'll have, the better product we'll make, and then the more robots we'll sell. And that momentum can just continue to accelerate, a little bit like the resource accumulation advantage you see with Tesla and their full self-driving.
We've talked a lot about, in those last answers, about the impacts on people. I've been in this industry for over 4 decades, and from the very start, those were the questions. Are robots going to replace all the jobs? Are they going to, make it so that we have lights out factories and we don't need any people? What will happen? I want to get your opinions on where we're headed here with this. I mean, we talk about how robots actually historically have saved and created jobs. That we look at this over a 4-decade period, we found that when robot sales in America go up, unemployment goes down. And when robot sales go down, unemployment goes up. Just the opposite of what it would be like if it's a job killer. But now, with the emergence of AI, there's additional issues being raised on this. So I'd like to get all of our panelists to weigh in on what they think the impacts will be on people. We'll start with you, Andrew.
Yeah, I'll start by saying our company's motto is the point of robots isn't to replace human touch, it's to extend human reach. How can we move humanity forward and allow people to solve increasingly meaningful problems? If we zoom out for a moment and think about what people were doing 100 years ago in the workforce, there'd be a 40% chance that you're working in agriculture. And today, that number, it's about 1.6%. We've got pretty healthy levels of unemployment. Before we got up here on this panel, we were talking about this concept of the 10 fisher person island. And it's an old parable that goes, 10 people get stranded on an island. At the start, they're all out there with sticks trying to go and spear fish just to be able to survive. Then one day, 2 of them, probably 2 of the 3 sitting to my left, they figured, hey, if we weave together this net, we could go and catch enough fish for all 10 of us. And then one went to go focus on housing, another went to go think about farming, and the society started to move forward. And that's exactly what we see robots doing. They're doing the dull, dirty, dangerous jobs that people don't want to do and shouldn't have to do. In the world I'm really inspired to build is one where my daughters grow up, they look back, and they're shocked that we used to let people waste their bodies and lose their lives just to try to collect a paycheck.
I think that, you said 4 decades. I don't know if I can go 4, but I can go 3. And in hardware, this stuff happens a lot slower than people imagine. And I remember that I remember a joke in the 90s that we used to say the fab of the future is going to have 2 employees. One's a security guard to make sure nobody comes in to hurt the equipment, and one's a dog to bite the security guard if he touches anything. And we're still not even close to that in fabs currently. So I think that this is the same question we've been talking about for easily 300 years now. And the only thing I see is that the rate of this productivity increase is getting steeper and steeper. And now we're at a place where a lot of people have to learn 2 careers in their life. And I've always said that I think there may be a point where this gets too complicated, and that might be the point where you have to switch careers twice in your life. That's probably a bridge too far, and we're going to have to think about the future of work when we get there. And I think that on the hardware side, though, that's very far away. I think this is actually now a much more interesting question with white-collar jobs, because on the AI side, things are progressing, incredibly fast.
I agree with everything my colleagues here, our panelists said. Maybe just to summarize, I see 2 trends. One is the enhancement of the abilities of the workers, and whether we are at home or at work, I think the robots are going to help us. That's one aspect of it. And robots, on the other hand, are going to open new markets for us. And that's basically, that aligns with what Jeff said, that robots bring the employment up. So from my side, I think that's all I can say.
Who? Yeah, just quickly, I would say, I think that the concern is not as much about losing the job. Maybe that's a concern, but the fear is what will I do next? So I think it's the change. People just need to be prepared that you'll be doing something different. We have factories, in one of our factories, we have, over the last few years, we have added 150 robots. We've not lost a single employee. We actually added more employees. We have added more flexibility to those factories. We have delivered more output and throughput through those factories. So I really don't see this as an issue at all. I think it's going to, as Arjuna said, it's just going to make us better, smarter, and make our work more efficient.
Well, it's a very hopeful outlook, and we certainly all hope that that's the way things work out. I mean, we see these technologies as to the benefit of people, and that many of the applications that we're talking about, that you'll hear about, I'm sure, throughout this conference, is attacking some of the most difficult challenges that we face. Sustainability of the planet, hunger, healthcare, elder care, which issue I worry a lot about these days. So we see robots and AI being overall very beneficial to society going forward. I want to thank our panelists. This was an outstanding discussion, and I hope all of you agree.